All right, welcome back to section 5.1 part 2 this time. We're still working with trig identities. Central question is still the same. What is a trig identity? How can we solve problems with them? This next page are all of the ones we've talked about so far. So the reciprocal and quotients, and then the Pythagorean identity. So basically, once again, let's not forget, we use all of these identities to help solve trig problems. Okay, so if we know one known, we can find so if we know sine, we should be able to find cosine. Or in this one on the right, if we know cotangent, we should be able to find cosecant. Okay, or for instance, if we know tangent and cosine, we should be able to find sine. Okay, now this next portion of the video, we have some more identities that we're going to work with. The first ones are called cofunctions. And then these are listed below, and then we have some that are called odd-even identities. All right. So we're going to use these to solve some problems. All right. Now the video goes all the way up to, I believe, we scroll up to example 8. The first video will go through example 4, and then 5, 6, 7, and 8 will be in video 2. All right. So we're going to start with example 1. All right. It says if tangent of theta is 1.28, so tan of theta equals 1.28. Find cotangent of this. All right, so we're going to go look at it. So look at what this looks like. Okay, looks very similar to our cofunction identities here. All right, now notice that it's all of these cofunctions, they all say pi over 2 minus your angle, pi over 2 minus our angle, pi over 2 minus our angle. Well, our problem right here, I'll actually move it down here, it says our angle minus pi over 2, so we need the pi over 2 first. So first thing I'm going to do is I'm going to rewrite this. Okay, and I'm just going to flip-flop these. Now, the signs have to go with them, so I'm going to do negative pi over 2, and then this is a positive angle. So all I've done is really just flip-flop these two, and the signs have to go with them. Okay, so what we want to do is we want to turn this original problem to look like our cofunction for cotangent. All right, so we've done that. Now notice that our cofunctions are positive pi over 2. Well, this one says a negative. So what we're going to do is we are going to factor out the negative. Okay, so I'm going to put a bracket here. So I'm going to factor out a negative. So when I factor out a negative of pi over 2, it turns into positive. Positive angle divided by my negative will turn this into it will turn it into a negative theta. Now, notice what we have here. All right. So, isn't this what we want? We want pi over 2 minus theta. So this is what we have. All right. So, all right, so our next step, okay, is I can take this negative and put it in the front. So I have negative cotangent of pi over 2 minus theta, and I'm going to stop. What is this part equal to? What is the cotangent of pi over 2 minus theta equal to? Okay, cotangent of pi over 2 minus theta is equal to tangent. Okay, so I'm going to replace cotangent of pi over 2 minus theta in for tangent of theta, and I'm going to drop down my negative. All right, so this is now what we need to look at. This is telling us that what we wanted to find this. All right, so our original problem was we were trying to find what this is equal to. Well, this piece right here, we've just proved that it's equal to negative tan of theta. Well, what's tan of theta equal to? Well, tan of theta is equal to 1.28. So what's negative tan of theta? So if I move this over here, okay, so if tan of theta is equal to 1.28, what's negative tan of theta? Well, it's equal to negative 1.28. There's our answer. So the cotangent of our angle minus pi over 2 is equal to negative 1.28. Now, these are very confusing problems, and I understand that. So that's why we're going to take this slow. We're going to make this multiple videos. All right, so example 2 we're going to do in class tomorrow. Okay, so everybody's on the same page. Example 2 is just like example 1. If you want to try example 2, you can try example 2, but we're going to do this one in class. All right. Now let's go to 3 and 4. To simplify trig expressions, start by rewriting in terms of one trig function or in terms of sine or cosine only. Typically, okay, we do this one. We want to try to turn everything into sine or cosine, okay? So we're going to skip example 3 because this one's a little harder. We're going to go to example 4, and what we're going to do is we're going to try to turn everything into sine or cosine using our trig identities. Okay, so we're going to go to example 4. All right, so we're going to say simplify secant of x minus tan of x sine of x. All right, so I'm going to move this down so we can work with it. So what we're going to do is we're going to try to turn everything here into sine and cosine. So I'm just going to start at the left, secant of x. Let's see if we can turn secant of x into sine or cosine. All right, so do any of these work? Well, any of these. All right, so this one doesn't deal with secant, doesn't deal with secant. All right, this one, secant's just on the wrong side. If we look at here, it says secant is equal to 1 divided by cosine. Okay, so I've turned secant into 1 divided by cosine. Okay, so our goal is to turn everything into sine or cosine. So minus tangent, if we go to the very first page, this is a little quicker this way. So if we go to tangent is equal to sine over cosine. Well, that works, so that turns it into both. Okay, so tangent is sine over cosine. Now, we don't really need these x's. We can put the x's in at the end. We don't need them right now. And then sine is already sine, so we're going to multiply by sine. I'll put it over 1, so we have all fractions. All right, so let's see here. So I'm going to just drop down my 1 over cosine minus, and then we have a multiplication problem here. Let's multiply sine times sine is sine squared, and then cosine times 1 is cosine. All right, so we have two fractions being subtracted, and we have the same denominator, so we don't even need to get a common denominator. What is this equal to? Well, if we're subtracting them, they both have a denominator of cosine, so I'm going to bring that over, and on the top we have 1 minus sine squared. Okay, anytime, okay, we can keep going. Our goal is to simplify this as much as possible. So anytime you have a squared, you should be thinking Pythagorean identities. So if we go to our Pythagorean identities, okay, down here at the bottom, we can see that we have this one that is dealing with sine squared, cosine squared, and 1. So I'm going to rewrite this one on that page. Let's see what that looks like. So we always know that we have sine squared plus cosine squared equals 1. Now, the nice thing about Pythagorean identities is we can rearrange these however we want. Okay, so look what we have on top here. It says 1 minus sine squared. If I subtract sine squared from both sides of the Pythagorean, okay, that goes away. I'm left with cosine squared equals 1 minus sine squared. Well, isn't that what we have here? We have 1 minus sine squared. What does that equal to? Well, it says it's equal to cosine squared. So I'm going to turn my 1 minus sine squared into cosine squared. And what do I have on the bottom? Cosine. Okay. So what have I essentially done here? Okay, notice. Okay, I'm going to rewrite this in long term. So this is really equal to, I have cosine squared. That means I have 2 cosines on top and I have 1 on the bottom. What I can do here is I can cancel out 1 on top and 1 on the bottom. What do I have left? I just have cosine. So all of that mumbo jumbo up here is equal to the cosine of x after we simplify. Okay. Now this is pretty confusing. We're going to do example 3 in class. We're going to turn all of these into sine or cosine, and we're going to do example 2 in class. Okay. And then after that, the next video we'll talk about example 5 and 6, which are the same kind of thing, and 7 and 8, which are the same kind of thing. So that's what we're going to do in the next video. All right, so don't worry, we'll get through this. It's pretty challenging, but I know you can do it. So this, I think this picture right here pretty much sums it up. Brace yourself. We got to do it. Okay. Have a good night.